Hello, my name is C.Oviedo and this is my teaching demonstration. In this video, I will walk you through a lesson I taught on slope and rate of change with my Algebra 1 students. You will see how students learn through hands-on exploration, real-world applications, and multiple representations. This lesson was designed to help students build a conceptual understanding of slope by examining how quantities change in relation to one another. Students work with hands-on materials, explore patterns, and connect the real-world context to linear relationships. The lesson aligns with Algebra 1 TEKS 8.2a, 8.3b, 8.3c, and 8.3d. The standard focus on interpreting the meaning of slope, representing linear functions in multiple ways, determining rate of change from tables and graphs, and applying slope in real-world situations. My learning objectives were for students to interpret slope as a rate of change, calculate slope from graphs, tables, and ordered pairs, and apply the concept of slope in different contexts. I also wanted students to explain the reasoning and make connections between representations. To activate prior knowledge, I began with 2 short video clips of cars traveling uphill and downhill. Students discussed which path was steeper and why. This helped them connect the idea of steepness to slope and supported early conjecture making.
Okay. Hi guys, welcome. Today we're going to talk about slope and rate of change. Have you guys ever heard of the word slope or rate of change before? No.
No.
Not really? A little bit? Do we have an idea of what it is? No, not really. Okay, good. I have some videos to show you here. So I'm going to start with video number 1. Can everybody see the screen here? Yes. Awesome. So I'm going to play it. And I want you guys to take some mental notes and tell me what you notice. Okay, not yet, but just look at it. Okay. So, let's talk about it. Let's give us 15 seconds to talk about it. What do we notice?
It's going up. It's going up a
It's
steep
going
hill.
up a steep hill. Okay. Is it going very fast? Is it going very slow?
Minimum. Minimum.
Más o menos, right? Okay, good. Let me go with video number 2. What do we notice in this one?
It's going really fast down.
It's going really fast down. So one of them went a little bit fast, but not so much, and this one went a lot slower. So what can you tell me the differences between the 2 videos? One is going up and one is going down. What can you tell me about the surface that they're on? It was what, smooth? Okay, that's a good one. It was steep, right? And it even kind of says it on the title. So we're looking about steepness. So when we look at steepness, which one do you think is faster? What do you think that connection happens with fast and steep? Like, you think the steeper it is, the faster it goes, or the steeper it is, the slower it goes? It depends what kind of steep. Good. So today we're going to be doing an exploration unit where you're going to be determining how steepness affects speed and how does that relate to math, okay? So we have a couple of items to do. So today we're going to be building some ramps. We're going to be using cardboard, some books, timers, ruler, and you're going to have a recording sheet to record your findings, okay?
Next, students engage in a hands-on toy car ramp investigation. Using cardboard, books, and a ruler, they measure the rise and run of the ramps and calculate a slope for different trials. This allows students to physically experience how slope changes when rise or run changes.
Okay, based on time, I paused the video to let the students get their materials. Each team has cardboard, some notebooks, calculators, rulers, a timer, and then each of them will be given a handout where they'll be recording their findings. Now, each team has 4 pieces of cardboard, all different lengths, all different sizes, and they will have the freedom to decide how high they want the rise and how long they want the run, right? Now, this is what you will do, class. You're gonna be getting your notebooks and you're gonna stack as many as you want. For example, here notice that the boys use some calculators. You can use any items to make your height a little bit higher if you want to. And then you're gonna get your cardboard and you're gonna place it so you can create a ramp. From here, you're gonna get your ruler and you're gonna measure in centimeters. What are we measuring on? Centimeters. So it's gonna be the smaller numbers, right? You're gonna get your ruler and you're gonna measure how high your ramp is and you're gonna record it in the right section. From here, you're gonna get your ruler and you're gonna measure how long the ramp is and you're gonna put it in your run, and then from there you're gonna make your calculations, okay? From there you use slope rise over the run to get your slope, and then you're gonna be doing the testings with your car by using your timer and seeing how long it takes for the car to get down, okay? We're gonna do this 4 times, and I want you guys to report every finding that we do, okay? Do we have any questions on this? No? You sure?
Yeah.
Okay, so I'm gonna go ahead and start the timer. Hopefully those take us around 10 minutes, and then we'll do our findings, okay? I'll let you alone. Okay, can we get it down? Who's keeping time? Who's keeping time? My timer. Come on, guys. Don't forget your roll. Who's keeping time here? Okay,
3,
and then we
2,
have the
1.
card, so Isabella's gonna roll the
1
cards.
second.
Okay,
Alright, let's do it again.
that's good. And then we're gonna write down the information. You Bruce?
3, 2, 1. 1 second.
Okay, we're measuring,
Okay,
good.
now Aaron, you're gonna go.
Remember, we're measuring in centimeters. Centimeters. So make sure you're recording the information.
At this time, the teacher is walking around the classroom monitoring the activity and helping any misconceptions that may be occurring throughout the lesson. I did notice that some students did forget to measure in centimeters, so I was able to correct those as I was going. I was reminding them on how to check for their slope, how to simplify fractions, etc.
Can we? I don't know. How can we check? Good. Okay, so the key,
No, you
we're
can't.
gonna measure our run. So we're gonna see from here para acá. So, what is my run here? 20, I wanna say 22? 22.
As students finish their exploration phase, we move into explain. During the explain phase, we connected their measurements to the slope formula and analyzed patterns from their results. I used Desmos to model rise and run dynamically so students could visually see how changing one quantity affects the slope.
Okay guys, it looks like we did all 4 trials already. So what were some of the findings that you noticed? Were there any patterns?
The higher, the faster it goes.
The higher, the faster it goes.
The
Did
lower-
you, okay, what else?
The lower it goes faster.
The lower, so the higher, he's saying that the higher you have your rise, the faster the car goes. What happens when you go lower on the rise?
It takes longer.
It takes longer, right? Did you notice any changes in your run? So when your run was very short, did it take a long time for the car to get there? No, right? It was also really, really fast, right? The longer the run, also the longer the car it takes. Okay, good. I want you guys to leave the timers alone, put the little cars outside, and I want you guys to look at my screen, okay? And we're gonna be talking about this specific thing. So let's say that this is what I have here, and we have a ramp, right? Now, in this case, we're gonna start at 0, 0, because that's my beginning, and I'm gonna say that this is my first point. What do you think will happen if I move 1 up? What do you think is gonna happen to my slope?
It gets steeper.
Is it?
Yeah.
Did it?
Yeah.
Yes. What happens if I go 2 up?
Even more.
Even more steeper.
Even more steeper. Do you think something happens if I change my run? What would happen if I go sideways?
I'll get longer.
How many units should I go sideways?
3.
Let's go 3. What happens? What happens to my slope? It got less steep, right? So what if I keep going sideways? Less steeper. Now let's move up. What happened?
Steeper.
So we're seeing a pattern here, right? Now we call usually slope the change of rise over the run, or the change of y over x. We also do have a particular formula for it. So let's say, like, based on your tables, we should be able to analyze that information. So were you guys able to answer these questions? Yes.
Yeah.
Okay. So as the rise increased, how did the slope change? Right now we saw it. As we rise the rise, how did the slope change? What happened? It got steeper. Which ramp had the steepest slope? So that one is going to be based on whatever your finding was. Okay? Now, describe the relationship between slope and steepness in your using your own words. So what is the connection that you find between slope and steepness? Are they related? Slope is what in terms of steepness? Or what is the relationship between slope and steepness? Rise over the run, right? So technically, slope is the steepness of a line. Okay, good. Okay, like I was mentioning, you guys said that slope was rise over the run, and you guys were able to find some of them. Slope is also known as the change of y over the change of x. And what is that one formula that we know when it comes to points? Y minus y over x minus x. So it doesn't really matter which representation they're giving us. We're all talking about the steepness of my line. Okay? Questions here? So far, no. Good. So here, we're gonna move to the next activity. We're gonna be placing our cardboard and our
Students then rotated through 4 real-world rate of change stations, including money earned, water tank levels, cell phone data plans, and temperature change. At each station, they calculated the slope and interpreted its meaning in context.
Okay, based on the information we're just given, we already know that slope is rise over the run, change of y over x, or the formula y minus y over x minus x. Now, right now we're gonna be working on stations. You are partnered up in your teams. I will be giving you 5 minutes on each station, and you're gonna be reading the scenario here. After 5 minutes, the timer will go off, and then we'll change stations clockwise, okay? Which means I'm going that way. Yes, so you guys will go here, 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 and so on and so forth. Now, you have to get a paper per person, so in each folder you're gonna find that there is enough papers for every single person. You're gonna talk about the real world scenario that you're gonna see, and you're gonna see how we can find the slopes even outside of this classroom. Okay? Do we have any questions on this activity? No. Awesome. So let's go ahead and open up our folders, and I'm gonna go ahead and start the timer. 5 minutes on the clock, and read the scenarios to your partners and talk about it, okay?
With definitions of amount of water you take, identify the slope, what does the slope represent in the context?
Is it? What are we doing? What's happening here? What times is what?
Feeling of water.
Feeling, so is that gonna be a positive or negative? Positive, because you're filling it up. Now, can we notice at what rate is it going up? How can I find the rate that it's moving? Wait, I could check what?
The graph.
The graph, okay, good. Talk about it. Talk about it with your team.
What grade is it? Identify the slope.
What is range?
What's the slope?
So look at what is the scenario telling you. What are we talking about? That's X and Y. So what do we notice here? What are they talking about? How many hours you work and how much money you get based on the hours you work. Can we make, or can we figure out what's the rate? How much are they getting paid? Look at the table. How much are they getting paid?
Actually,
How many hours are we working here?
it's negative 6.
How much are they getting paid? And then for 2 hours? Okay, so can we make up what is the rate? So how much are they getting paid?
30 cents, nigga. That's the lie, bro.
12 every
6.
hour, right? So can I say that that's my rate? Yeah.
7. 6/3. Oh my god.
Okay, the timer went off. We already finished all stations. Do we have any questions that you notice on each of the scenarios here? No? So in station number 1, we talk about money earned. We're talking about how much money you earn for each hour you work. Scenario number 2, they're talking about a water tank that's filling up. And we need to figure out how long it's taking for the water tank to fill up. For scenario number 3, we're talking about a cell phone plan, and we're trying to find how much they're charging us and how much internet service we get from it. And for scenario number 4, we're talking about a temperature change. Now, what do you notice about each scenario? Each of them have what? Graphs, or what is this called?
A table.
Table, right? So usually we would use a table to find the changes, right? Now it is telling you exactly which one is your x and which one is your y. Am I able to identify the slope with this information? Yes, right? So we're able to see the patterns that are happening across in the negative, in the real world situations, okay?
Ideally, I would take more time explaining each of the scenarios with the class and we will have a class discussion, but due to time issues, I decided to move on into the evaluate. To assess student understanding, I used a short exit ticket that requires students to calculate slope, determine a rate of change, and explain what slope represents in their own words. This allowed me to check both procedural fluency and conceptual understanding.
Okay guys, I'm gonna ask you to please place all the papers inside the folders. Based on the information that we saw today, we're gonna give a little exit ticket of 3 questions, and that's how I'm gonna determine if we were able to figure out what slope and rate of change is. Now, this is gonna be our exit to the classroom, so you are to work on this individually. Please do your best to not copy from your partners, okay? All papers should be inside the folders that are in the middle. Do not have any papers with you, just you own papers. Okay? Remember, do not talk to anybody, just put in the findings. Okay guys, looks like we're done. Let's go ahead and put all the papers in the middle of your desk and I'll pick it up. Make sure to put the calculators away as well and the pencils.
And that was our lesson. This lesson really highlighted the power of hands-on learning. Students were engaged, collaborative, and willing to share their reasoning. The RAP investigation helped build intuition for slope before introducing the formula. A few students struggle with negative slope and interpreting units, so in the future I will provide more guided practice in those areas. Overall, the lesson supported algebraic thinking and aligned with instructional practices emphasized in this course. Thank you for watching my teaching demonstration.